This is Todd's Dodge Garage, and I'm Todd. We are continuing a series that I have started on the interior component testing and repair on the first gen Dodge Charger. The last video I did, we focused on a power pack. The power pack is what controls the electroluminescent lighting on these cars. It's very common for it to go out, very common for the electroluminescent lighting not to work. So we went ahead and showed how to safely handle that unit. It puts out a lot of voltage, and to diagnose it and test it. Tonight, I think what we're going to do is we are going to be at an actual instrument cluster out of a first gen Dodge Charger. This cluster got sent to me by a customer for a full restoration. This was or is the original cluster out of their car. We can test it. Certain things work, certain things don't work. But in many instances, your gauges don't work. Your fuel gauge doesn't work, coolant temperature gauge or oil pressure gauge don't work. Speedometer is going to work. That's mechanical. That's operated by a cable. It's likely that your amp gauge is always going to work. That's the main power feed in, and that's what the power coming out of that powers the entire car. It's 50-50 whether the tach works or not. The tach can be good. The tach sender can be faulty. But we can go ahead and do the basics of diagnostic and testing. I'm going to show you how you can yourself at least make some base determinations whether you have to consult expert help or if you can tackle the job of repairing yourself. Without further ado, let me get set up and I'll be right back. Okay, it's a little more difficult to do this on the bench with one hand than what person might think. On a 66 Dodge Charger, the tach sending unit is separate. It is mounted underneath the glove box, actually next to the power pack, and it looks like this. On a 1967 Dodge Charger, this unit is incorporated into the tachometer, into the back of it. You will not see that can. That is what drives the tachometer, converts the signal that it gets from the negative side of the coil, and it does its magic and ultimately tells the needle where to read. This here is your tachometer, RPM times 100. You can test this yourself. Now, disclaimer, I am not going to be held responsible if you fry your tachometer by testing this. You can test it yourself with some very low voltage, AA battery, or 2 or 3 of them. For example, we're going to set up here, as you can see on my machine. It's hard to see, but that's 0.88 volts. That actually should equate, if the tach is working and if it's calibrated, that should equal 1,000 RPMs. Let me flip my switch on here. And the tach just jumped up. It's right at 1,000. We'll turn it off. We'll turn it back on. That tells us a couple things. It tells us the tachometer is a functionable tach. It tells us it's not roached or fried. It tells us that it's at least calibrated at the low RPM range. We can adjust this voltage up. 1.9 volts is going to be about 3,000 RPMs. So we'll go to 1.9. And notice the needle is higher. 0, 500, 1,000, 2,000, 3,000. So now what we're noticing is the tachometer is slightly off by about 200 RPM, roughly, at 3,000 RPMs. Now we don't need to go any further. This tach, along with all these gauges, is going to get completely disassembled, taken apart. Each component is going to be thoroughly cleaned, inspected, tested during the restoration process. Once this goes back together, this will be recalibrated properly. Could be that the tachometer is dirty. It could be that it's sticky. We haven't done anything with this cluster at all. I haven't even looked at it prior to setting up for this video. I don't know what works on this gauge cluster and what doesn't. So we know the tach works, and that is a way you can test it yourself. If you're not sure if your tach sending unit is good, if you have a question there, just disconnect it and just put power directly to the back of the tachometer. On your cluster, the back of the tachometer, you're going to have two studs. One is going to be isolated with a brass washer. That is your ground side. The other one is going to be isolated with a fiber washer. That's going to be your input side. That side is also closest, as you're looking at the gauge cluster, to the oil pressure and coolant temperature gauges. So with that, let me get set up and we will start testing individual gauges. I'll be right back. Okay, all you need for this is one of these, set to ohms, on the 200 scale. That's it. Now I will disclaimer this. This is not a guarantee that your gauges are going to work or function properly if they test good. All you're doing is checking for continuity across the two studs. All that's going to do is tell you if the wire internally is broken or not. What you're looking for is approximately 20 ohms of resistance. Now, trying to do this with one hand is tricky. Okay. So, can we see the meter? We're just going to test. I can already tell you just by looking at this, someone has been in here at some point or another. I can tell by the way that this gauge is set in this housing. Either it's been jarred or jerked around or something, someone's played around with it. I'm just going to touch the two terminals. Now we have about 38 ohms of resistance, 40 ohms of resistance. It's considerably higher. It's about double what we would want to see. It tells us that the wire is not broken internally, but it does not tell us anything other than that. Let's test the oil pressure gauge. Now my hand is right in the way. Now that's open. I can tell you right now, without even taking this gauge apart, without going any further, that gauge is probably compromised. The wire is definitely broken. And I will show you internally what a gauge looks like here momentarily. We're going to test the fuel level gauge at this point, and that is this gauge on the back that has these three terminals. This terminal is your 12-volt power source in. This here is nothing more than a noise suppressor for your radio. That's all that is. Actually, you can just take that off and throw it out. It's not even needed. Most people don't have AM radios now. Your main power feed for your car, black harness, comes in here. That is because there is a voltage limiter built into the fuel gauge, which I will show you in a fuel gauge. And that cuts down 12 volts to roughly a fluctuating 5 to 7 volts, let's say. Your fuel gauge, your coolant temperature gauge, and your oil pressure gauge all run off approximately, let's say, 5 to 7 volts. So testing this fuel pressure, fuel level gauge, we have 20.9 ohms of resistance. That is perfect. Again, for a baseline preliminary test, what you can do in your garage, that's all you can really do per se. If you're going to go any further, there is specs that you can get. They're very difficult to find. You can email me and I can give them to you. In other words, if you want to know how the gauge is calibrated, what it's supposed to read at empty, half, and full, for example, for the fuel gauge, same thing for the oil pressure and temperature gauges, things like that. Amp gauge, if anybody knows these Mopar amp gauges, it's nothing more than a magnet that's inside of here, so there's no testing that, and it's going to get taken apart anyways. The speedometer, we don't need to test. We're going to take that completely apart. I mean, that's, you know if your speedometer works. So here's where things can get derailed fast. That's all the testing really most people can do in their garage themselves, is with a multimeter and testing continuity across the 2 terminals, and on all 3 gauges, oil pressure, coolant temp, and fuel gauge, it's about 20 ohms of resistance. That's what you want to see. Here I have a fuel gauge that I have taken out of a cluster. I have not done anything with this one. It's just one of my fuel gauges that is in one of my core spare cluster parts. And I've got gauges up there and in there, and I've got gauges down in those drawers and down there. And so this is just a gauge I grabbed. But we're going to get this opened up here, and I will show you what the inside of a fuel gauge looks like. So if you're going to open up your own gauges, again, I want to issue a word of caution. These are riveted shut. Right here and right here. And you've got to drill the rivets out, which is fine, easy enough to do. But you've got to just be prepared. You've got to bolt them back together or something. These tabs that I'm pointing to here and here will likely break if you're not extremely careful when you bend them open to remove the face from the gauge, which I've already done that. You can see the rivets are gone, and I've already done that. So we're going to open up this gauge very carefully. The needle is on here, and you can jar this needle. I don't know if you can see it, but this wire, this red wire, I rebuilt this needle a while ago. So this red wire is a replacement wire that I needed when I repaired the electroluminescent needle on this needle. But be very careful removing the face, because you can jar, you can dislodge, you can damage the needle. Now, if you're going to remove the needle, here's what you're going to do. Hold the gauge with one hand, with your thumb and forefinger, support it there, and all you do is just slightly relieve some pressure. With your other hand then, you're just going to very carefully pull the needle out of its resting spot. And when you handle the needle, handle it very carefully, because if you bend any portion of this needle, it's likely that the electroluminescent will not work anymore, and you're going to have to send it in to somebody that, like Todd's Restorations, that can repair these. So we'll set the needle aside. This is the inner workings inside. This is what makes a fuel gauge work. This is identical to an oil pressure gauge and a coolant temperature gauge. The only difference is this part here that I am pointing to. See that? I'm spreading. That is a mechanical voltage limiter. This is a bimetallic strip. It's wrapped with nichrome wire. And here's where it gets interesting. No one reproduces that nichrome wire. They haven't for 20 years. No one has it. There's a few gauge rebuilding places, Todd's Restorations being one of them, that actually has the correct Stewart Warner wire in stock. But once these places run out, that's it. I mean, there's only so much of this wire left on the planet. No one reproduces this wire, and they have not for a very long time. It's a resistance wire, and given in this length of wire from terminal or from stud, wrapped around the bimetallic strip to other stud in that length of wire, it's about 20 ohms of resistance of resistance. These gauges work off current, not voltage. And people assume they work off voltage. They don't. What happens is the bimetallic strip is just that. It's bimetallic. It's two different metals. And so by having resistance wire and creating resistance, which is what your, in this case, since this is a fuel gauge, your fuel sending unit does, it heats up, the wire heats up. Well, the wire heats up, it heats up this bimetallic strip. This bimetallic strip actually bends. It actually bends. And if a gauge is bad enough, when it's been fried, this will be in the shape of a horseshoe. Not quite that bad, and it'll stay there permanently. At that point, the gauge's junk, can't be rebuilt. It's never going to calibrate properly. What happens is these gauges, again, work off 5 to 7 volts. How did they do that 57 years ago? With this little guy. Again, the voltage limiter. This set of points opens and closes very rapidly. In fact, you can't test it with a multimeter. You need a test light. And even at that, it's going to pulse very rapidly because this just opens and closes so fast. You have 12 volts coming in on your 12 volt stud. And on the back of your cluster, it says, it'll tell you 12 volts, 5 volts. On the back of your cluster, right up here, this one says 12 volts. Here it says 5 volts. And here it says S for signal. The nichrome wire that's in these gauges, that's used to build these gauges, cannot handle 12 volts of voltage. It's good for about 10 seconds, literally about 10 seconds, and then it's toast. What makes this nichrome wire so special is A, the resistance value, and B, it's fabric wound. You cannot have a metal wire wrapped around a bimetallic strip. It's a direct short to ground. So there's only a couple places on the planet that have the correct wire, so that raises the question then, what is everybody else using? I can tell you what everybody else uses. They use this. It's called magnet wire, and it is 100% incorrect. One thing you will notice is they put a warranty on it knowing it's incorrect. The next time you're thinking of getting your gauges done by somebody on your first gen Dodge Charger, call around, ask them what their warranty is. I guarantee you it's not more than 6 months. The reason for that is that magnet wire is going to fail. It's not designed to handle the constant on-off, and load and heat cycles that the nichrome wire that Stewart Warner used when they built these gauges used when they produced these gauges. Now this is a really nice gauge because you'll notice that this is in really good condition. It's probably a little hard to see. Here, we'll try to get in here. I was hoping I could get in there and see the... There we go. So actually, and what's happened with this one is if you look closely right here. You can almost see the fabric fibers on this set of windings and on this set of windings. But if you look real close right here, the fabric windings are gone. This is the metal wire contacting directly the voltage limiter. That's a direct short to ground. So what's going to happen is if I put power to this right now, this is going to peg open and it'll just bend like this. Or what will happen is it'll weld itself shut. And that's what typically happens, and typically what fails on these clusters is this set of points will stick closed. By doing so, it sends 12 volts directly from that stud through that wire right through the set of points, right down through the bimetallic strip, down to this stud, right into this wire, and poof, you got 12 volts going through this nichrome wire. It not only overheats this bimetallic strip, which damages it, but it fries the wire. So when you're testing for continuity on your gauges, all you're doing is making sure that the wire is connected between this stud and this stud. And so you can get some baseline readings if you're not sure what's going on with your gauges. In other words, if you test this and you show open like we did on one of our gauges, you don't need to go through any further diagnostics with your car, pulling sending units and dropping gas tanks and, you know, pulling oil pressure senders and blah, blah, blah. If it's open, it's open. It's in the gauge. That point blank right then and there. Now, I'm not saying you don't have other issues with the car, but as far as the gauge is concerned, that's what's wrong with the gauge. So I just wanted to go through that a little bit tonight and show this and show the inner workings of what these gauges are. They're electromechanical. There's nothing digital about them. They do not self-calibrate. And so everything is done by hand. There's lots of time into rebuilding these gauges. This wire is hand wrapped. So when I rebuild a set of gauges, every turn you see is hand done. And so it takes time to do this, and then it takes time to calibrate it properly. I rebuild every needle when I do a job, and so the needle will get stripped. It'll get brought down to, the paint will get stripped off. It'll get, of course, tested, but the wire gets replaced. Because remember, this year, it's 2024, it's about 57, 58 years old, these clusters are. And so one thing I do want you to notice is for the electroluminescent wire, you'll notice I used that magnet wire. Okay? You can use magnet wire on electroluminescent lighting. You cannot use magnet wire to rewind your electromechanical gauges. So keep that in mind. Magnet wire is nothing more than wire that has a coating on it. And if you did not use a wire that has a coating on it, you're creating a direct short to ground, especially with the wire contacting, it's wrapped around the needle here. It's actually touching here, here, here. And you'll notice that that's all part of your needle assembly. And ultimately, goes through this stud here, goes through this stud here, which ultimately contacts the bottom of the gauge. So if you end up with a direct short to ground in your electroluminescent lighting, you're going to fry one of your needles extremely quick. So it's very important that when you're handling your cluster, once you take the bezel off of it, that you handle it extremely careful. because here again is again, I didn't do anything with this cluster. I didn't pre-do anything. So this is original wire. And you can almost see how it's sort of churned. It almost looks plasticky. That's because it was a fabric wrapped wire at one point, but over time it overheats and it sort of solidifies it almost. It's tough to explain, but keep in mind you have 230 volts alternating current going through that little wire that excites that needle, which then in turn causes it to glow. You'll notice that the wire that's used to power the electroluminescent gauge face is about 20 times that size. It's roughly about 20 times thicker wire going to your gauge face than it is your gauge needle. So it's very common for that needle to burn out as time goes on. And so, you know, couple tips and tricks there, a couple things to look for. So if you're having issues with your cluster for your first gen Dodge Charger, a couple things to look for. I hope that really helped out. Until next time, be safe, have fun. We'll talk to you soon.